Chapter 4-7. We done via PowerPoint. Okay? Now, with that said, there are some things I'd like to review. Do you remember, when do we have an inverse? No. I'm going to be going back and forth between the PowerPoint and the Smartboard today, okay? Everybody with me on that? Now, the PowerPoint that I gave you spots to take notes there if you would need to. Do you all understand that? So this is your notes for section 4-7. Any questions over that? Okay. Now, with that said, okay, chapter 4-7, inverse trigonometric functions. Do you remember, in order to have an inverse, you must be a one-to-one function, which means you must pass the horizontal line test. What does a one-to-one function indicate or mean? What does a one-to-one function indicate, and what does that mean? Where are we at? Anybody? On your unit circle, write that box in over there on that sticky note and put it in the middle of your unit circle. What does one-to-one mean? Absolutely not. To be a one-to-one function, that means for every x value, there exists one unique y value. Do you remember that? There exists one unique y value. Parabola. If I have y equals x squared, when x is 2, then y is what? 4. When x is negative 2, then y is 4. Does y, the value 4, go to one unique x value? Does the value 4, which is the y value, go to one unique x value? No, this is not 4 goes to 2. 4 also maps to negative 2. The x's are different, but the y value of 4 is the same. That means, think of it this way. You have twin girls. Are they going to have the same boyfriend? It's not likely. Okay, that's not a unique boyfriend, is it? No. Okay? In order to be a one-to-one function, every x has to choose one unique y. Every x must choose one unique y. As soon as 2 chose 4, negative 2 could no longer choose 4. So remember the horizontal line test? The horizontal line test said that if it crossed it in 2 places, then it was not a one-to-one function. Do you remember the vertical line test? The vertical line test said if it crossed it in one spot, then it was a function. Y equals x squared is a function, but it's not a one-to-one function. Do you remember this, yes or no? We took the test of this a long time ago. Okay? Recall that for a function to have an inverse, it must be one-to-one and pass the horizontal line test. Do you all recall this, yes or no? I mean, to an extent. Well, wipe out the cobwebs. Now, this is the sine function. Okay? Sine of x does not pass the horizontal line test. Okay? Sine of x does not pass the horizontal line test. Do we all understand that, yes or no? The reason why it does not pass the horizontal line test, because it's a continuous function. So in order for it to pass the horizontal line test, do you know what it does? is snips it, and it takes one increment of it, okay? And says, from this starting point, which is at negative pi over 2, to this ending point at pi over 2, I am a one-to-one function. Do we understand that, yes or no? If I take the whole graph of sine, I am not a one-to-one function because it crosses it in more than one spot. Do we understand that, yes or no? The horizontal line would cross in more than one spot. So, can you tell me what the domain of this is? The domain would be what? Domain deals with which values? Is domain X or is domain Y? Domain is X. So where does it start? I want you to take your highlighter and I want you to highlight this region right here. Okay? I want you to highlight that region right there. What region am I talking about? I'm talking about this part right here. Okay? That's where you'll have an inverse. Take your highlighter and highlight that. Now, next. Sine of x has an inverse. What's my domain of this? Where does it start? No, it does not. Negative pi over 2. It starts at negative pi over 2, and it ends at pi over 2. Do we see that? Do you remember seeing that notation? I understand you don't like it, but this is why in, our math classes we need to remember things. Now, what's my range? My range is looking at my lowest y value and going to my highest y value. My lowest y value is at negative 1, and my highest y value is at positive 1. I don't know why it won't erase, but understand that that's not supposed to be there. Don't know why. Okay, there's your domain and there's your range. Yes, no? Now, when you have inverses, what do you know? What happens to your values whenever you have inverses? What flips? The x values now become the y values now become the x values. Do you remember that? So whenever we're talking about inverses, slide 3, the sine inverse is defined as this. Now here's where you guys all go like, oh, Mrs. Yoder, this does not make sense. Y is equal to the arc sine of x if and only if the sine of y is equal to x. Now what does that mean? And if and only if means you can read it forwards and backwards. True statement? Okay? I hope we're all taking notes, right? And not just viewing them up there. Y is equal to the arc sine of x if and only if the sine of y is equal to x. What your mind needs to read this as is what angle has a sine of the x value. That's what that says. What angle has a sine of the x value? Also, arc sine is written exactly the same as sine to the negative 1. Your calculators do not have arc sine on them, but your calculators do have sine to the negative 1, cosine to the negative 1, tangent to the negative 1. Do we understand that? Okay? They mean exactly the same thing. That's like saying Christopher and Chris, Jessica and Jess, William and Will, or Will, right? Do we all understand that, yes or no? Next. Notice how those all went away. Sorry. The domain. Remember we said earlier that the domain of our sine function was from negative pi over 2 to pi over 2, and that our range of our sine function, that snippet, was from negative 1 to 1? And we said that the inverses do what? They swap. So if we're talking about the domain of y equal to the arcsine of x, that was the range, so it now becomes our domain from negative 1 to 1. And our range was our domain, and it's negative pi over 2 to pi over 2. Do we understand that, yes or no? Because they flip-flop. So now, it's going to ask for, what is the arcsine of 1/2? What does our brain need to translate that as? What does our brain need to translate that as? What angle has a sine of 1/2? That's what your brain needs to think about. Now get out your unit circle. Now, in other words, this says the sine of y is equal to x. Y represents an angle. Y represents an angle. More importantly, that angle needs to be where? It's our y value. Is y the range or the domain? Y is our range. So what is the range of the arcsine? Come on, what's the range of arcsine? Arcsine and sine negative 1 are exactly the same. What's my range of arcsine? Negative pi over 2 to pi over 2. Do we see that? That's what my range is. So now I'm looking for an angle whose sine is equal to 1/2. So what is theta, which is y? So tell me, look at your unit circle. What angle has a sine of 1/2? Well, that's 30 degrees, okay? Is 30 degrees the only angle that has a sine of 1/2? What other angle has a sine of 1/2? What is it? 150, which is going to be 5 pi over 6. Now here's my question, people. It has to fall within my range. Does 5 pi over 6 fall within my range for sine? Do you understand that that's in quad 2? And I'm looking for angles that are in where? I'm looking for angles in quad 1 and quad 4. Do we understand that, yes or no? So what does that imply that my answer has to be? It has to be 30 degrees. Do you understand why we have the restriction on the domain and the range? Does that make sense? So my only answer, going back to the PowerPoint, my only answer is 1/2. Does that make sense, yes or no? Okay, let's do it again. Where'd it go? Where'd it go? Aw. Okay. The sine inverse. Now, why is it saying sine inverse this time? It's the same thing as the arcsine. Do we understand that? So now, I'm looking for the sine inverse of the square root of 3 over 2. Okay, so what does our brain need to think? What's our brain need to think? Our brain needs to say, if it's asking for the sine inverse of the square root of 3 over 2, that's the same thing as saying the sine of theta is equal to the square root of 3 over 2. In other words, what angle is theta? Okay? Now, keep in mind that our range is from negative pi over 2 to pi over 2 because we're dealing with sine, right? Okay? So what angle has the square root of 3 over 2? The square root of 3 over 2 is going to be 60 degrees, which is pi over 3, or what other angle has a sine value of the square root of 3 over 2? I'm sorry? What's it going to be? 120, which is going to be 2 pi over 3. Now, this is what your brain's going through. Your brain is finding all of these angles. And then what does your brain have to eliminate? The ones that are not in quadrant 1 and 4. Well, what angle does not lie in quadrant 1 and 4? This is not in the range. Do we understand why it's only going to be 60 degrees? Yes or no? Do we get that? Are we good? It's very important that your brain understands this. Okay, next. Here's the cosine curve. You're now on page 4. Now, is this going to be a one-to-one function? You can see the horizontal line that it drew. Is it going to be a one-to-one function? No, it is not. So again, what it does is it goes ahead and it's going to give you a range of where it's going to work. Why won't it give me my little thingy down there? I have to come over here to see it. Do you see it gives you a range where it is a one-to-one function? Again, highlight that so that you can see that nicely on your graph. Okay? So that's the area that we're looking at. In other words, my domain of this graph is what? What's the domain of this thing? 0 to pi. What's my range of this thing? Negative 1 to 1. Okay? So now, what does this imply? If we're looking at the arc cosine, that means that my domain of the arc cosine is from negative 1 to 1, and that my range of the arc cosine is going to be from 0 to pi. Do we understand that our domain for arc sine and arc cosine are both the same from negative 1 to 1? Our ranges are what's different. They're pi units, right? But one is shifted to the left, okay? Next, the inverse cosine function. Exactly the same as sine. What angle has the cosine of whatever value it is? Does that make sense? Okay? And then the domain we already said of the arc cosine is from negative 1 to 1. I would highlight that if I were you. And the range of it is from 0 to pi. I would do this for both of them. I would go back to your sine graph and I would highlight that so it's easy for you to find. That's on page 5 for cosine. And for sine, it's going to be on page 3. I would highlight that, domain and range. I would highlight page 3, domain and range of the arc sine, and then page 5, the domain and range of the arc cosine. Okay, because now we go on, and our first example says the arc sine of 1/2. In other words, what angle has a cosine of 1/2, right? That's what our brain needs to read. What angle has a cosine of 1/2? And that's going to be pi. Now understand that what two quadrants are my angles needing to lie in for cosine? For sine, it had to be 1 and 4. What about for cosine? 1 and 2. Do we understand that? So you're never going to have an angle in quad 3, are you? Okay? It's either going to be 1 and 2 for cosine and then 1 and 4 for sine. Any questions over that? We good? Next. Cosine inverse of negative square root of 3 over 2 is going to be 5 pi over 6. They're wanting you to see the two different ways that you can write it. Are we good with this? Any questions over sine and cosine and why those angles are the only angles that work? Next trig function brings us to tangent. Well, if I draw a horizontal line across this, is this going to be a one-to-one function? I'm on page 6. And it will not be, okay? So what it does, sorry. I know, that's the craziest thing, isn't it? Okay, so what it does is it says, okay, well, it's not a one-to-one function. I can see that it's not a one function, so I'm going to restrict it, and the area that I'm going to restrict is going to be from its normal period, which is going to be from negative pi over 2 to pi over 2. It's negative pi over 2 to pi over 2. Okay, do we see that? Now, can you tell me the domain of that highlighted region? Negative pi over 2 to pi over 2. And what is my range of the highlighted region? Negative infinity to infinity, because it keeps going forever and ever and ever and ever and ever. It never touches that asymptote. Do we understand that? So this is going to be from negative infinity to infinity. Do we understand that? Which means now, what is going to be the arctangent? What would be the domain of the arctangent? Negative infinity to infinity. What's going to be the range of the arctangent? Negative pi over 2 to pi over 2. Do you see how this all works? Yes or no? Here's the arctan, if and only if, what angle has the tangent of x? And we're going to get the domain negative infinity to infinity, and we're going to get the range from negative pi over 2 to pi over 2. Do we understand that? Again, you want to highlight that region. This is what you want to highlight in your notes, because this is what's very, very important. Okay? Notice that tangent and sine have exactly the same range. That's helpful, right? Tangent and sine have exactly the same range. 1 and 4, okay? Next, example. What angle has a square root of 3 over 3? Now do you understand why I gave you guys all the sticky note? That sticky note is going to be very, very important. That's going to make you not have to think so hard. I've literally put it on the middle of my circle just like this, so that I have my unit circle there, and I'm able to do quick calculations. Any questions on that? Okay, so your sticky note, should be in the middle of your circle. Tangent of 30 degrees is equal to the square root of 3 over 3. Tangent of 45 degrees is equal to 1. And then the tangent of 60 degrees is equal to the square root of 3. And put that on there for the people who are not here. Okay? You're going to put that on a note card or sticky note and put it right in the middle of your circle. Easy calculations. Do we all get that? So back to the PowerPoint. That wasn't the right one. Okay. Why does it go whenever I... Okay. Part B. Tan inverse of the square root of 3 is equal to pi over 3. And we're going to have the tangent of pi over 3 is equal to square root of 3. Do we all understand where this is coming from? I talked to you about it with sine and cosine. You should be okay for this. Now, this is how they look on a graphing calculator. I could graph these ourselves, but there's no sense in wasting class time, and you can see them right here. Okay? Your calculator is very, very important that you be in radian mode. Radian mode. You cannot graph the sine curve in degree mode. Okay? We good with that? You must be in radian mode. So, the arc sine, you literally put in your calculator as sine inverse. For Inspire users, if you hit the trig button, you're going to see sine to the -1, cosine to the -1, tangent to the -1, cosecant to the -1, secant to the -1, and cotangent to the -1. That's what it looks like. Now, if you think about it, there are reflections over the line y equals x. Okay? Arc cosine and arc tangent. Okay? Are we good? Yes, no? Okay. Puts everything in for you. Now, when you're typing in your calculator, again, what mode do you need to be in? Must be in radian mode. And if I literally grab your calculators and do this so that you guys can see how to do it. Okay? Make sure your mode is in radian mode, and all you have to do is type in, first problem, cosine inverse of 0.75. And it's going to give you 0.7227. That's exactly what you type in. Make sure that you need to be in radian mode. Now, arc sine is 0.19. The arc sine is 0.19. I can't put in arc sine, can I? Our calculators don't have arc sine. What our calculators do have are sine to the -1. Do we all get why we have to use that now? Now, I want you to notice something. These are x values. Are those x values in our domain? What's the domain of sine and cosine? Negative? No, that's the range. That's the angle. -1 to 1. Is 0.75 and 0.19 in between -1 to 1? So I will get an answer. However, go to the next one. Arctan of 1.32. Now, what is my domain of tangent? -infinity to infinity. So does that work? It absolutely works. What about this one? Arc sine of 2.5. Do you see why your calculator automatically gives you a domain, go to, or quit error? Because 2.5 is not in my lovely little range. It's not in my domain from -1 to 1. Do we get that? Yes or no? So that's why it kicks it out and says, nope, that does not work for me. Any questions over that? Next. Okay, now, you guys aren't going to like this part. It's very simple. It's composition. Composition. And it's going to have a whole bunch of this written here. And I'm going to not do this here. Okay. If two functions are inverses, then f of f inverse of x will equal x, and f inverse of f of x will also equal x. Now, we did composite functions or composition previously. If you recall, I give you a function, let's say y is equal, or f of x is equal to 3x minus 4. How did you find the inverse of that? Do you remember we replaced f of x with y, then we swapped out x and y, then we solved for y, and then we replaced the y with what? the F inverse. Do you remember us doing this? Way back at the beginning of the year. We did this, okay? Then we went ahead and proved that those two were inverses. And the way that we proved that they were inverses was by doing the composition of them, remember? I went ahead and I did f of f inverse of x. Well, f is understood to be 3x minus 4, but I'm actually doing f at x plus 4. So every place I saw an x, I plugged in the x plus 4 over 3. Do you remember that? So I had 3 times x plus 4 over 3 minus the 4. The 3's canceled out. X plus 4 minus 4, those canceled out, and I got x. That proved that those were inverses. This is review. We did this way back in the day. Trig is done exactly the same way. But what we're trying to show you is that the sine of arc sine equals x, and that the arc sine of sine equals x. Okay? Can I move on? Okay. Now, what this means is, it is not a big deal at all. It's literally the sine and the arc sine cancel out. The arc sine and the sine cancel out, and you're going to have x equals x, y equals y. Cosine, arc cosine, cosine. Do you see x equals x, y equals y? Tangent and arc tangent, x equals x, arc tangent, tangent, y equals y. That's all it's telling you, that whenever you put one in for the other, that they cancel each other out. Do we get that, yes or no? Okay. Because now that brings us to the next slide. Maybe. Okay. Slide 11. All it's saying is those cancel out if and only if this angle right here, which is negative pi over 2, is that in my range. Well, what does sine go from? Negative pi over 2 to pi over 2. So is that in my range? Absolutely works. We're good to go. Okay? B, is 5 pi over 3 in my sine range? Well, where is 5 pi over 3? 5 pi over 3 puts me where? Puts me in quad 4. So is it going to work? Does it work? It absolutely does. Okay? Does that make sense? Okay? Do we see that? Okay? Any questions over that? Oh. This one is a beautiful problem. The problem that it gives you a great example of, the tangent of the arc cosine of 2/3. Now, I'm going to do this on the smartboard because I think this is going to kind of blow your mind. Those don't cancel, do they? Since those do not cancel, you have to try to make it cancel. The only way that's going to work is if you do a little swapping of things, okay? We are going to let u equal the arc cosine of 2/3, which means that I have this equation. Agree? How do I get rid of arc cosine? What would cancel that out? Cosine. So what we're going to do is take the cosine of both sides. Do you see that? Those cancel out, and now I have that the cosine of u is equal to 2/3. Can I put that on a triangle? Can I? I absolutely can. So if I put this on a triangle, here's u. Cosine is going to be adjacent over hypotenuse. Now what side is adjacent to u? The bottom one, which is 2, and then this is going to be my hypotenuse, which is 3. Can I find my opposite side now? I can, by using what? A squared plus b squared is equal to c squared. So a squared plus 2 squared is equal to 3 squared. A squared is going to be equal to 9 minus 4. So a is equal to the square root of 5. Okay, tonight's homework, folks, is chapter 4-7, written A, 2 through 46 even. I'll finish that example tomorrow. Does anybody want to know how to do it right now? All you have to do is now you found A. So this is the square root of 5. But now I want to know what my arc cosine of that is. Well, that's understood to be u, isn't it? So now what is tangent? Tangent is opposite over adjacent. So that's going to be square root of 5 over 2. And that's the final answer. Yeah. Okay, that's why I finished the problem. Okay, tonight's homework, guys. Don't forget to do it. 2 through 46 even. That was fun, wasn't it? What's the matter with you?